Hi everyone, we are solving the IIT JAM Geology paper of 2024 and here we are going to solve some questions in today's class. Darcy's law quantifies the volume of groundwater flow based on what? Okay, so we have four options given. Now what is Darcy's law? Darcy's law is a fundamental principle in hydrogeology that governs the movement of groundwater through porous media. It relates the rate of flow of groundwater to the hydraulic gradient and the hydraulic conductivity of the aquifer material and the cross-sectional area through which the groundwater flows. Okay, so mathematically, Darcy's law is expressed as Q is equal to dH dl. That's the formula, where Q is the volume of groundwater flow per unit time, that is the flow rate. K is the hydraulic conductivity of the aquifer material. And A is the cross-sectional area through which the groundwater flows. Okay, and dH by dl is the hydraulic gradient, representing the change in the hydraulic head per unit distance. So this equation indicates that Darcy's law quantifies the volume of groundwater flow per unit time, making option B per unit time as the correct answer. Okay. Still, we need to discuss the other options also. Why aren't they correct? Now, option A, which says per unit surface per unit surface area of the aquifer, it says the first one, is incorrect because Darcy's law, as I have already said, it deals with the flow per unit time, not surface area. Similar things apply to the other two options also. Okay, let's move over to the next question. A tunnel with vertical walls and arched crown is constructed through a set of sedimentary beds. The thickness of individual beds is significantly less than the wall height of the tunnel. For which of the following conditions one of the tunnel walls becomes unstable? Now let's discuss about this. The stability of the tunnel walls in sedimentary beds is influenced by the orientation and dip of the beds relative to the tunnel axis. So let's analyze each of these options over here. The very first option is the tunnel axis is horizontal and the beds are horizontal. So in this scenario, what is happening? There is no dip in the beds and the weight of the overlying material is distributed evenly. So therefore, there is no significant risk of instability due to the orientation of the beds. Okay. Moving over to the second option, that the tunnel axis is parallel to the strike of beds and the beds dip 45 degrees to 60 degrees. See, when the tunnel axis is parallel to the strike of the beds and the beds dip steeply, like between 45 degrees to 60 degrees, the tunnel is excavated across the bedding planes. Okay. In such a situation, there is a higher likelihood of instability because the tunnel walls are exposed to potential sliding along the bedding planes due to the force of gravity acting perpendicular to the dip of the beds. Okay, and this can lead to the collapse of one of the tunnel walls. Hence, we can say option B will go, of course. Coming to option C, which says the tunnel axis is parallel to the strike of beds and the beds are vertical. Now, the tunnel axis over here is parallel to the strike of the beds and the beds are vertical, right? That is what the point mentions, third one. So if the beds are vertical, there might be stability issues due to the potential for block sliding along the vertical bedding planes. However, this scenario is less likely to result in instability compared to steeply dipping beds. Okay. Coming to D, the tunnel axis is perpendicular to the strike of beds and the beds are vertical. Now the tunnel axis is like perpendicular as it is said. Now in this case, what happens? The tunnel is excavated parallel to the bedding planes, minimizing the risk of instability. Therefore, the scenario is less likely to result in unstable tunnel walls compared to option B. Okay. So yes, option B is our correct answer. Moving over to the next question. Next we have a plunging fold will not show a V-shaped outcrop pattern on a planar ground surface if the plunge of the fold axis is. Okay, what is a plunging fold first of all? Now a plunging fold is a fold where the axis of the fold is tilted at an angle compared to horizontal. This tilt affects the way the fold is exposed on the ground surface, especially when combined with a sloping ground surface. Okay. And why does a V-shaped outcrop pattern occur? First of all, it occurs due to erosion. Okay. Now imagine erosion slowly wearing away the rock layers. Okay. The exposed layers will follow the shape of the fold due to the varying dip angles, or it might also occur due to anticlines or synclines. Now in an anticline, what happens? Oldest rocks in the core, the V points, the V the V points in the direction of the plunge, and in a syncline that is in the youngest rocks in the core, the V points opposite the direction of the plunge. Okay. Now, what are the conditions for not showing a V-shaped pattern? Matching dips can be one reason. Okay. Now, when the plunge angle of the fold axis, it matches the dip angle of the ground surface in the same direction, then the exposed layers will appear parallel to the ground slope, negating the V shape. Okay, imagine walking along the slope. The exposed layers would just seem to dip further with no obvious V shape change, right? So yeah, your answer would be A, which means equal to the dip of the ground surface in the same direction. Okay, that's your correct answer. So yeah, let's keep it till here in this video. If you have any kind of queries, then you can post down your comments below in the comment box. And if you are preparing for any kind of job examinations, then you can just call us up and join our classes for that. Study materials, live lectures, recorded lectures, portal access, and everything would be provided to help you out to crack the exams. That's it for today's video. Thank you for being with me till the end. Do check the description box just below this video for more details.